Hi guys, this is the Ruby Mob. Nice to see Kevin and Musa here with us today. Today we're going to be discussing the book we usually discuss, Well Grounded Ruby, Well Grounded Rubies. But first we'll start by randomizing. So I'm going to share my screen. It's just me and Kevin, so we're just going to randomize the two of us. Oh, Mose, should I randomize you too? Awesome. All right. Let me open my terminal. It's taking ages. There it is. So IRB. Okay. So Mose, you can pick numbers between 0 to 5. Yes. I can't hear you. Are you muted?
Just try 3 and 5.
3 and 5. Okay. Mose, it's 3 and 5. Kevin, please pick your two numbers. Sorry, I can't hear you.
0 and 4.
Okay, 0 and 4. The remaining ones are for Getty, which are 1 and 2. Awesome. Now let's randomize. Run 5. The first one is 4, which is Kevin. Second one is 2, which is me. Third one is 0, which is Kevin. So sorry, Kevin. You'll have to take us through today again. So just give us a few minutes to set up. And I'm going to get back to you in a few.
Okay, guys. Can you guys get me? Okay. Can you get me now? So, from our calendar, I see previously we discussed converting the converter and class methods versus start methods. Next, we should cover, we started talking on constants. We left a small bit that involved modifying constants. Okay, let's see, where was that? Constants. Oh, somewhere here. Okay. So, this is where we stopped last time, resigning and modifying constants, where we saw if you have a constant a and you try to reassign it, it will throw a warning, but the return value will be what you have assigned it. Yeah, like you can see, there's a warning already initialized constant a. Previous definition of a was here, but you can see the return value. Okay, so but the problem of this, as we saw, there was a bit here. So Ruby is a dynamic language in the sense that anything can change during runtime. So engineering constants to be an exception to this will theoretically be possible, but will introduce an anomaly into the language. So if you reload program files that you have already loaded, and the program files included the constant assignments, so forbidding constants would mean that many file reloading will fail with a fatal error. Sigu explained, gave an example of this, yeah, in the last. Okay, so to begin from this part where we are modifying constants. So let's create a class. Let me call it person. Then is this? Oh, this is IRB. Let me use Pry. Why do I love Pry? Oh, it's just I prefer. I think with Pry it's colorful. Yeah, assuming I have I've loaded maybe all this IRB. It's all with the IRB. It's all white. You want? Let me say. It's a bit confusing than if it's colorful. Okay, so I have a class. Let's use Oira. Then I have. Let me have a constant. Let me call them P language. Languages. So maybe he does. There is Ruby, JavaScript, and an Android. Okay, let me. Django. Okay. So I have that. And so initially we saw that if I wanted to access this constant, if I do this, if I do this, what will happen? Moses, Getty, any ideas? From our previous, this is just a recap of our previous, before we start modifying the constant. So what do you think will happen at this point? If I just call the constant this way. A lot of silence. Moses, any ideas?
Expect an array.
Yes.
An array.
An array. An array. Yes, and you get it. Another like initialize constant. Okay, awesome. So we have an initialize constant because for us to, when we define it like this, it will check for this constant in, let me say, in the, it will not automatically know that it is in here. So if we are to call it, you have to tell it that, and using that constant lookup notation and do that, yeah. So this we are specifying that this, we are accessing the constant from the Oira class, and we have this. So so changing the other sense in which it's possible to change a constant is by making changes to the object to which the constant refers. So for example, if we have the only way of modifying is like if you want to, we are adding content to the constant using this, how do we call this? This operator, okay. Okay. So for example, let me use the example we have. So if I have P, first I have to specify that it's from that, yeah. Then I'm adding, I want to add a language. Let me say, there is Java. Let me add that. You can notice here it is, yeah. If we don't want to use this, we can use like an array, right? Let me do that. This time, let me we can do that because so in this case, the constant is just like an array. So different ways of modifying. Different ways of modifying the element. We can use that operator. We can use push. As you can see, the changes there. We have added Java and C++. Okay, so you can notice here there is no warning. We are not reassigning the constant, but we are just adding elements to the constant. So there is no warning here because there is no redefinition. Rather, we are just modifying an array. And that array has no particular knowledge that it has been assigned to a constant. Yeah. So what's really the difference between reassigning and modifying an object? So in this bit, the difference between reassigning a constant name and modifying the object reference is important, and it provides a useful lesson in two kinds of change. So changing the mapping of identifiers to objects by assignment, and changing the state or contents. So what we are doing is changing the contents and the state. But the previous one, which involves we were redefining, we are changing the mapping of the identifier. Any questions, Getty, Moses, up to this bit?
Sorry, I'm fine. I'm good.
Okay, Moses.
I'm also good.
Okay. So we were dealing with constants, but with regular variable names, there is no warning when you're doing any reassignment. So for example, if I do this, Then again do this. There is what's the value of A at this point? I just did A equal. So if I do change the value, we are reassigning the same variable. With variables, there are no warning or no errors. Okay. If you put together the topics in this chapter with some of the examples you have seen, you start to get a good overall picture of how Ruby objects are engineered. They derive their functionality from instance methods defined in their classes and their ancestors, but they are capable of learning specific individualized behaviors in the form of singleton methods. Let's go to this next bit. Nature versus nurture. Okay. Moses, are you okay up to this point? Any clarifications and questions on constants?
You can proceed.
Okay. So, nature versus nurture. So the relation between classes and the instances is essentially a relation between the general and the specific. A familiar pattern from the world at large. So we are used to seeing the animal kingdom in general or specific terms, and likewise, everything from musical instruments to university departments, libraries, to pantheons of gods. To the extent that a programming language helps you model the real world. Conversely, the real world supplies you with the ways to organize your programs. So these are like organizing your program is like the properties or methods available for you to modify your objects. Yes, Getty?
I think this statement that you're talking about is relating to how a program can relate to the real world. Like how we can create an object of an animal and tell it to work as a method. And how the world itself is modeled to make us create our program.
Okay, thank you, Getty. As you can see, inheritance, like the superclass to subclass relationship, it mirrors the general or specific ratio closely. So moreover, if you hang out in object-oriented circles, you'll pick up some shorthand for the relationship. So for example, the phrase is usually, for example, we can say an example. For example, if we say an employee is a person, so what that means is like employee inherits all the attributes and properties of person. So if we say Ezin inherits from magazine, we say an Ezin is a magazine. So similarly, a magazine object is a publication. So if magazine inherits from publication, then we say that. So for example, like we have, if we had this a class maybe A inheriting from class B. If we have that, we don't have this class, so I have to have B. I have to have the class B and A. Yeah. So if we have this, so we have a class B, and then we are saying that A inherits from B. So like it's like A is a B. Okay, let me create a class. Human. He is human, is a human, okay. And then I have another one. Inherits human. So this means I have the Getty class inheriting from human. So in this case, with the is a relationship, I can say Getty is a human. Yeah. So Ruby lets you model this way. You can get a lot of mileage out of thinking through your domain as cascaded. Inheritance based chart of object. So Ruby even provides is a method that tells you whether an object has a given class. So we can confirm if Getty that is that is it. Interesting. Why did that bring false? Oh, if I create an object, then I ask if get if a dot is boom. So why did this bring false? So that does is yes. Yes, Moses.
Maybe you can try human is human Getty. That is in brackets.
So let me just go back here.
Okay.
So Ruby even provides the is a method that tells you whether an object. So the is in our case we were comparing two classes, but is you should check if an object has a given class, either as its class or as one of its superclasses. So in short, why that was not working is this. We are using this to confirm for objects. In our case, we were looking at classes, but you noticed we created an object. Then after creating an object, it's like we are checking if that object belongs to that class. Afungua ile. So like you can see in this case, we have a magazine object. We are creating an object. Then we are using is to check that this object we created, we are checking if it has the class magazine or it belongs to the class magazine. Okay. Organizing classes into family trees or related entities with each generation a little more specific than the last can confer a pleasing sense of order and determinism on your program landscape. Organizing classes into family trees or related entities with each generation a little more specific than the last can confer a pleasing sense of order and determinism on your program landscape. So, but Ruby objects, unlike objects in other languages, can be individually modified. So if we have an instance of a given class, an instance of a given class isn't stuck with the only behaviors traits that its class has conferred upon it. We can add methods on the object. Then furthermore, the classes can also change. It's possible that if you had an object with some properties or methods, it can gain some methods. As we will see in the next section. So in languages where you can't add these methods to individual objects or to classes that have already been defined, so an objects class and the superclass of that class tells you everything you need to know about the object. Any questions up to this bit? Clarifications? Okay. So for example, if the object is an instance of magazine and you're familiar with the methods provided by the class magazine for the use of its instances. So in this case, you have a class magazine defined somewhere. Then in the class, you have, the methods, inside. So you know how the object behaves, as in, the messages you'll send whenever you're creating the object. So, but in Ruby, the behaviors of an object can deviate from those supplied by its class. So assuming you had a class with some methods, but in this case, you want the object you're creating to respond to another method. So there is a way you can do that. So I think we can do this. So we have a class, let me say animal, for example. So let me say we have a method that here I can fly. Oh, something happened. Let me do the. So I use the single. So the method fly, and it's output to be I can fly, and so in this case, if we create an object of animal, we create an object of animal, it can only respond to the that. What about if we wanted it to maybe hope? We don't have that, yeah? So assuming we want it to hope. So we'll create now this our object is A, we want it to hope, yeah? Then we want it to say, yeah, I don't fly, man. I just hope. Okay, and so now if we do this, expecting. So you can notice A is an object out of the animal class, but the animal class only involves, it has the behaviors or properties of only animals that can fly. But if you want it to, maybe you want to modify the behavior, or change or add, so this is a good way to do it. So this is like, it's like, this is now like a singleton method, a method that only belongs to that object. So this hope only belongs to this object A. If we create another object B, animal object B, and we call hope on it, it's undefined because it's not available for, but it's only available for the object A. So if we wanted to, if you wanted to add some property for B, maybe B just works. Yeah. So this bit, if we call that, okay. Any questions up to this point? Clarifications? Okay. So what I just done demonstrate the capabilities the object was born with aren't necessarily the whole story. It can gain some on the way. It's just like when you are born, you cannot walk, but with time you'll teach yourself how to walk, how to run. Yeah. Okay, so thus the inheritance tree, the upward cascade of a class to a superclass and superclass isn't the only determinant of an object behavior. So this just means that if we have a class and the class inherits from, it has a superclass, as in the class you created inherits from another class, it does not mean that the object you created is restricted to the methods in the superclass and the class. Okay? Get your question as a question.
So, what if we find a method that is available to objects, and then
Okay.
you hear me?
Let me see.
And then you bring me as a mic. But I can hear myself.
Maybe try.
Okay. So, what if we had a method? What if we had a method that is available to all objects, like dot to s or dot to I, and then we singleton it to a single object?
So you're saying if we had a method like?
A method that already exists.
Oh,
Like to A or to S. And then we singleton it to a single.
okay. We can always try that. So it's like you're doing an overriding. So it's like, so assuming, let me have a class of numbers, yeah? Then I want I have a method. I want to convert the number to string. Let me use to string. So if I want to convert the number to string, I want it to be like to return. Okay. Maybe this time it won't. Let me just put that. So I have that. Then let's add that. So assuming I have we have a numbers class, yeah. So I have maybe n. We create a numbers object. Oh, we have a numbers object. So with n, I want like so I know that if I do 1 dot to s, I'm expecting a string 1, yeah. But in this case, you have our object n, and this time if we call to s on it, expecting what we told it to do in our class, which is just to output string. So I think you're asking if this is like so basically here we are doing method overriding.
I was asking.
Yeah.
If we singleton it to a single object.
Oh. So
we create an object of number, and then we give itself that method, and it's the only one to use that method if it will be available to all the other numbers.
So, now being that I've used to s, let me use so we have the object n, yeah. So we like do n dot. Let me use to s. Okay, awesome. Then another one. Okay. So so why so you're asking if we can do this with this already in here, or assuming it being that because here we have a numbers class, we have defined to s in it, but again we are we are just changing. Actually, at this point we are changing its behavior by again calling to s on it, but we are changing its behavior such that the output is now this. So if we have that, and this time we call, what do you guys think will be the answer?
I think it will bring another one.
Another one. Boom. So what has happened is that so this is like an example is maybe we have changed the behavior of the object created. So an example, if you have a class person and you have the method sing, the way you will sing and the way I sing is different. So what we have done here is like this object, the way it does it, that it responds to s is by doing this when you create any other object. But this time, when we create the n object, you want it to respond to this to s in a different way. So that when we call it, it responds this way and not it overrides the initial behavior.
Okay, how about now? What if we call to s on any other number? Will it still be string? Will it output string?
Okay, if we do this, it will output the string of 5 because this is okay. The way Ruby will interpret this. Okay, let me just okay. The way Ruby interprets this is First, we'll check where is this n really defined. Then it will check up and see, oh, n is an object of the numbers class. But then after that, it will see, oh, so n is valid. What then next it says, I should be responding to this message. Then it will see that this message, oh, in my class, this is what I should be doing. Though in this, at this point, it knows that what I should be doing is returning this. But here now, so assuming before I do that, let me just use an object that is not existing. So in this case, we don't have Z anyway. So in this case, I'm expecting undefined probably method in our class, or we have not defined it anywhere. So this point, I'm expecting that. But in this case, now we have 5. We want string. So the way now Ruby will but okay. Moses, are you getting me?
Okay. Yes, you're very audible.
Okay. So this bit I have a number, but we know that if you have a number, the methods that it can respond to, so it can respond to, so what Ruby will see is, oh, this is a number. Then it will continue. It will see that its message, the message it should be responding to is to S. Then it will see maybe probably in the, this is like actually an integer. So in the integer class, it will see that, oh, I am able to respond to the message or the method to S. So it will return the string 5. It will return the string 5 and not this one. So if I do that, so I think doing that, if we check at 5.methods, just to see the methods it responds to. Okay, there are hell a lot to SI, you can see is one of them here, yeah? But how about if we check quit? Oh, we had a n actually. So we had n. How about we check the methods that n can respond to? So there is there is that. Okay, there is that. Do we have 2s anywhere? No. So these are is there? Okay, it cannot respond to 2s, but it, yeah, these are the only methods it can respond to. But the moment we are calling the 2s on it, it will check first where it will first check where the messages that it will respond to from its class. If it's available in the class, then it will execute it. Otherwise, if it's not available in class, then it can, and it's one of these, then it will respond to it. Okay, guys. Where are we? Where are we really there? Back to nature. Oh, I think we were in this. Oh, I see. It's 3:59. Let me just read through the section here. So the most use case, the most common use case for adding methods directly to objects is adding of class methods to class objects. So this scenario is just like defining class methods. Yeah. So the vast majority of singleton style. So a class method is just a singleton method. Yeah. So the vast majority of singleton style method definition you'll see maybe something like this. We have that is like the object, then the method. So this will be a class method definition. So adding methods to other objects, for example, magazine, or those are the ones that is possible, but you have to do it carefully and selectively and with the design of the program in mind. So in most cases, object individuation, this is some topic in chapter 13, okay? It has to do with dynamically determined conditions at runtime. So for example, if you might add accessor methods to objects to match the names of database columns. So the accessor methods, they attribute reader, attribute accessors, attribute writer, just to match the names of database columns that you don't know until the program is running and you have queried the database. That's one example. Then, or you might have a library that has special methods that you have written for string methods, and that you want only certain strings to have access to it. So that's a scenario of creating a class object. I mean a class method. So Ruby frees you to do these things because an object's class is only part of the story. Its nature, you might say, as opposed to its nature. And there's another piece of the puzzle, modules. So our module is like a Ruby constant, which we have seen several times in passing, which will meet up. So the next chapter actually is actually about modules. Yeah, I think. I see our time is up, but we can summarize this, or next time we can start from the summary. Actually, yeah, because the summary will be like a recap of what we have done in this chapter. Okay, thank you guys for being part of the mob. Thank you, Moses. Thank you, Getty. And that's the Scrum, the mob for today. Next up, we'll begin from the summary section, then on modules. Okay. Bye, guys.
Bye.